Hi, my name is Matthew Bell, and I'm doing my presentation on Neptune and Vulcan, their predictions and whether they were real or not. So let's dive into this. Okay, so first things first, let's talk about the prediction of Neptune. So Neptune was actually predicted before it was observed. Um, so this was because there were irregularities in Uranus's orbit that could not be explained by Newton's gravitational theory or law of gravity. The Uranus seemed to move faster than it should have been moving. These irregularities could be explained by Newton's law of gravity. However, if there was just another planet beyond Uranus affecting the orbit of it. Okay, so that's how Neptune was first predicted to exist. And then using mathematical predictions by French astronomer, I'm going to butcher this, so I apologize, Urbain Le Verrier, Johann Gottfried Galle was able to observe the planet on September 23rd, 1846, confirming Newton's law of gravity. So this was a really big night for astronomy, as not only were Newton's laws of gravity verified through prediction, it just showed that astronomers and scientists could really predict things very well. They saw, Uranus was being weird. They knew that something must be affecting it gravitationally, and lo and behold, it was planet Neptune. They were correct and verified Newton's laws of gravity, which was very impressive. Moving on, so predicting Vulcan. So much like Uranus, Mercury also had some irregularities in its orbit. And since Neptune was such a huge success story, it was thought there was another mystery planet affecting Mercury. So here is a map of the solar system from the early 1840s, 1850s. So as you can see, we got Earth, Venus, Mercury, and then Vulcan, which is twice as close to the sun, roughly, as Mercury is. So very close to the sun. And they thought this planet was affecting Mercury's orbit. It's the same French astronomer as before, in 1859, predicted mathematically using Newtonian physics that a planet was disturbing Mercury. So in this case, the hunt was on. He, mathematically predicted Neptune, and it was observed just a few years later. So people were scouring the sky in search of this mystery planet Vulcan. So there were a few cases of astronomers claiming to actually have observed this planet, but it turned out that they were just actually observing sunspots instead. They didn't know this at the time, but it was later discovered that they were just looking at sunspots and not an actual planet or asteroid or anything like that. Okay. So disproving planet Vulcan. So obviously no one has found anything on planet Vulcan. And this is when Einstein kind of stepped up to the plate here. And as we know, Einstein's theories of relativity greatly change how we understand physics and especially gravity. So it turns out that the mass of the sun creates such a curvature in space-time that it changes how Mercury was predicted to orbit. So using Einstein's, equations of general relativity, one can predict the exact orbital revolution that Mercury has. The exact orbital revolution, which is insane. It also predicts Neptune as well. So it doesn't just disprove Vulcan, it also helps prove Neptune as well, even though we already know exists, but it's the equations still match up, which is useful. Astronomers still looked for the planet Vulcan, however, just to be sure, cover their bases. Even after Einstein came to play, but after searching through 7 total solar eclipses, it was deemed that Vulcan did not exist, and that Mercury was by itself so close to the sun, and relativity was the player and causing it to be weird. So, moving on. Let's talk about Newton and Einstein. So now the disproval of planet Vulcan does not mean that Newton was wrong or that his equations were wrong and that Neptune was wrong. It just means that Newtonian physics just break down when it comes to large masses and fast speeds. Einstein solved this problem, with his theories of relativity. Einstein's equations are also equivalent to Newtonian equations at smaller masses and speed. So Einstein kind of unified the big and the medium I don't want to say small because quantum is very different as well. So can't quite do that. But yeah, Einstein unified um, stuff we observe on Earth and then stuff we observe in space. So that was pretty impressive. So that's it. That's it for my presentation. Here are my citations and references. Thank you for watching.